This next example is one where there are two logs, but they're not log equals log. It's equal to a 3. So what we're going to do instead is use one of our properties. Because it's plus right here, we're going to use this property. Now it looks different because there's x's in there. It doesn't matter. Still the same process. Log base 4 of x times x plus 12 equals 3. So I pulled this guy and this guy, put them inside parentheses, and multiply them just like the m and the n there. Because now at this point we have a single log, which means I can convert it. 4 to the third equals x times x plus 12. And that's a regular old quadratic. We love quadratics. Distributing over here, I get x squared plus 12x equals 64. Okay, x squared plus 12x, got to get it equal to 0, equals 0. Okay, now I'm going to try and double bubble it. Negative 64 and adds to 12, positive 12. That's going to be positive 16 and negative 4. So x plus 16, minus negative 4, x plus 16 equals 0, means x equals negative 16. X minus 4 equals 0, means x equals 4. Maybe. Remember that we have to check our answers and find out if they're extraneous. Now, I could have done the domain at the beginning. This time I'm going to show you how you can just take the inside stuff and check it in there. So x plus 2 is this guy. We're checking for extraneous. So if I plug in negative 16 for x, I get negative 4. That's a no-no. Uh-oh. No, no. So this 16 is actually not, negative 16 is not a solution. It is now extraneous. All right, let's try the other one. Let's see. We've got x plus 12. Is it 12 or 2? 12. Oh, there we go. X plus 12. If we plug in 4 now, 4 plus 12, that's 16. Check. That one's okay. Now our other log had just an x in it. So if it's just x, if that's positive 4, then that one's okay. So there's the other way that you can check for extraneous solutions. Our actual answer, our only answer, is that x equals 4. All right, here we go. We've got a problem over here where we've got a log equals a log. If log base 2 of this stuff equals log base 2 of this, those two things have to match. They have to be equal to each other. Finish solving. I get x equals 16. Now, is that extraneous? Let's check. Using domain, x minus 6 is greater than 0. X has to be greater than 6. Yes, 16 works. So that one's done. All right, this one says ln of some stuff equals ln of some stuff. Therefore, those stuffs need to be equal to each other. When they're equal like that, there's no change of base, there's no converting, there's no e involved. All we're saying is these guys match, so they can get out of here. Minus x, minus 5. I get 3x equals negative 6. Divide by 3. X equals negative 2. Okay, let's go back and check. We'll just do it by the problem. One of them says x minus 1. If I plug in negative 2 minus 1, I get negative 3. Uh-oh. That's a no-no. Right? Uh-oh. No, no. So this is actually an extraneous solution, but I have no other values. That just means that I say there is no solution to that one. Look, if I'd even plugged it into this other one, right? 4 times negative 2 plus 5, that would have been negative 8 plus 5, which is negative 3, which again is not allowed. So this was domain check. All right, next one. Okay, this one says solve, blah, blah, blah. It's reminding you to check for extraneous solutions. Okay, we've got 2 logs, but they're not equal to each other. They've got this 3 over here. I'm going to combine them into one log. Log base 2. It is adding, so that means we're going to multiply inside. Right? Multiply. That equals 3. Now we're down to a single log. I can then convert 2 to the third equals x times x minus 2. Okay, just like the other one, distribute the x through. Move that 8 over. It's got to be equal to 0 to solve. It's quadratic. Okay, that one's a nice easy double bubble. X minus 4, x plus 2. Each one of those gets set equal to 0. This says x equals 4. This one says x equals negative 2. Now let's check. Can I have 4 for an answer? Well, this one just says x. That one's okay, right? Check. This one says x minus 2. 4 minus 2 equals 2. That one's okay. It's positive. Whoops. Okay, this one over here. So this one on the right, x equals negative 2. Well, if that's the value here, that one does not work. It's negative. And since this is just x, sorry, big old fat arrow going there, it's an oh no no. Cross that one out. We'll say our final answer is x equals 4. And that's it.